Good day, my group and I will be presenting our beach profile and longshore current data. My name is Daniela Duran.
Daniel McLaughlin.
And Caroline Down.
So what is longshore transport? This will represent the sea, the bottom portion, and the top portion will be the beach. And then the red dot here will represent the sand particles. So with that said, let's begin. The wave direction moves to the prevailing wind direction. When waves move to the coast, they move onshore as swash. And when they move downslope, they come as backwash. The swash always follows wave direction and the backwash always is vertical due to the gravity. Thus, the material like sand is progressively moved along the beach. Now this movement is the longshore drift. Similar movement takes place in the water close to the shore. The water moves forward to the beach before swash forms. Water moves back off beach as a result of backwash. This movement is the longshore current. So this is the longshore drift and then the longshore current. The aim of this longshore drift experiment was to measure the transport of sediments along the coastline. The amount of time it takes for the swash and backwash to cause the orange to zigzag to the end of the 30-meter line determined that time for the experiment.
For the Hopkins Beach, we were at the north side of the village. The wind direction was southwest and it moved 5.1 knots. And the GPS point was at north 16.867 and west 088.28529. The wave height was 32 meters.
To do the longshore transport, firstly, the temperature and the wind speed was measured using a handheld anemometer. After that, light piece of cloth was placed in the air and that showed the direction of which the wind is going. We ran the transect 30 meters out into the water. Then we got our orange or any closing device that is not harmful to the environment and we threw it out. And the time, we timed it to see how long it took to come in. This was done 3 times at Hopkins. On trial 1, it went 15 meters and took 22 minutes. Trial 2, 20 meters and 12 minutes. Trial 3, 15 meters, 16 minutes.
Now we have arrived at Placencia. We used the Placencia beach in front of Cozy Corner. The wind direction came from southwest and the wind speed was 3.1 knots. The GPS point that was used was north 16.5177 knots, west 88.36677. The wave height was 43 meters.
In Placencia, we also did 3 trials for the longshore transport. Trial 1, we received 6 minutes for 3 meters. Trial 2, 20 minutes for 15 meters. And trial 3, 15 minutes for 10 meters. The reason why the time is close to the distance is because in Hopkins, we did our trial at 3 different spots, while in Placencia, we did everything at one location. And the wind was stronger in Hopkins than it was in Placencia.
So what is beach profiling? Beach profiling is a surveying technique used to measure changes in the contour of a monitored beach. So comparing profile lines recorded at different times makes it possible to measure changes in the distribution of sand on the beach. Tracking these changes over long periods provides marine ecological survey with data to identify seasonal, annual, and even track long-term trends in beach erosion and aceration. The data is used to inform beach management decisions of the local and state level, and the data is shared at the Marine Beaches Conference.
The beach profiling procedures. First of all, beach profiling is used to get the morphology of the beach. It allows companies to make better decisions when they decide to build near the coastline. The method used to carry out this procedure was the Emery method. Materials needed were 2 poles, a string, a level, a GPS, and a transect tape. Multiple transects were done at 50 meters intervals. This is used to get the elevation of the beach and locate the berm and also find the water depth. If the berm moves inward, it is proving that erosion is happening to the coastline. To start off, you need a permanent structure which is known as a benchmark. You will need to record that spot with your GPS. Then you take your 2 poles and extend them to the length of the string, which will be 3 meters, and then it has hit the meter mark on the second pole. You then put the level, and the level must level off with the string. That as a result will cause us to move the string above the meter mark or below the meter mark. That will be done from the benchmark until you reach the berm, and that will show the difference in elevation. Once you reach the berm, get your GPS and mark that point one more time to see if the berm had moved upward or if it stayed in the same place from last time's reading. You then get the height of the water level.
Beach profile in Hopkins. This first table shows the benchmark reading. This graph is for the first reading. We started off by a coconut tree on a property edge. Our readings went from 1.11 meters to 1.15, 1.22, 1.44, 1.5, and 1.47 at the berm. From there, we went 3 meters out, and the height of the water was 0.29 meters. The GPS was at longitude 16.86748 and latitude 88.28526. At the berm, the GPS reading was at longitude 16.86756 and latitude 88.28513. The second reading, we went from 1.7 to 1.11, 1.4, 1.18, 1.33, 1.56, 1.62 to 1.37. 3 meters after the berm, we got a depth of 0.51. This was done from a cement foundation. The longitude for GPS was 16.86725. Latitude 88.28527. At the berm, the GPS reading was at longitude 16.86733 and latitude 88.28503. Our last reading for Hopkins, marks went from 0.93 meters to 1.06, 0.95, 1.06, 1.34, 1.37, 1.4, and 1.2. 3 meters after the berm, the depth was 0.48 meters. This was done also from a coconut tree. GPS, longitude 16.86685, latitude 88.285. At the berm, longitude was 16.86694, latitude 88.28487. We then went to Placencia. In Placencia, we started off in front of Cozy Corner by the hammocks from a coconut tree. The GPS mapping there was longitude 16.51779 and latitude 88.36677. The readings went from 0.77, 1.25, 1.57, 1 meter to 1.36 meters. 3 meters after the berm, we got a depth of 0.32 meters. The longitude at the berm was 16.51784 and latitude 88.36665. The second reading was from a coconut tree in front of a home property, and this GPS reading was at longitude 16.51736 and at latitude 88.3666. The readings went from 0.92, 0.88, 0.73, 1.22, 1.57 to 1.44. 3 meters after the berm, we received a depth of 0.48 meters. At the berm, the GPS reading was at longitude 16.51745 and latitude 88.36643. Our final reading for Placencia was done from a coconut tree in front of Nirvana. The GPS reading there was at longitude 16.5169, latitude 88.336623. The readings went from 0.88, 1.38, 1.6 to 1.52. 3 meters after the berm, the depth was 0.37 meters. At the berm, the GPS reading at longitude 16.51699 and at latitude 88.36612.
So why was it important to carry out these experiments? For one, the longshore transport experiment was important so we could know in which direction the sand particles were moved along the beach. And for the beach profile, it was important for us to carry out this experiment because it helped us to determine if the beach has been eroded over time or not. From our recorded data, in Hopkins, we noticed that the elevation went decreasing while in Placencia was more stable. So we can say that in Placencia there is more control over erosion than there is in Hopkins. Thank you for listening. This has been the end of our presentation.
Thanks.
Thank you.